So there's tons of ways of determining the greatest common factor, but I'm going to show you the easiest way I think of being able to do it. And that's going back to your factor trees. But let's rewind here again. What does greatest common factor, or as we affectionately know this as GCF? Right. The greatest common factor, according to the Pearson textbook, if you read this, is of two or more numbers is the greatest factor the numbers have in common. Okay, wait a second. Let's look at the McGraw-Hill book. It says this is the largest factor shared by two or more terms. Shared, common, same thing. So how do we go about doing this then? Well, it's actually a lot of fun and pretty easy. Look at this example. It says determine the greatest common factor of 126 and 144. So here we go. 144, there you go. 126, there you go. Break it down. Now, 144 is easy because I know that that is 12 times 12. 12 times 12, you can break that down again to 6 times 2 and 6 times 2. How lovely. And keep the factor tree going by going, okay, that's 2 times 3 times 2. That is 2 times 3. And there's that last 2 there. So there's the prime factorization of 144. Let's go to our another number here, which is 126. Now, 126 can break down again, but if you're like me and you go, oh my goodness, I can't remember how this breaks down, try this. 126, you know is even, is divisible by 2. That's fine. But now let's start looking at that and saying, oh, okay, that's 2 in 63. Now, the cool thing about this now is I can carry this 2 down and go, okay, 63 I know is 9 times 7. And check this out. You now have 2 here. You have the 3 times 3 here and the 7 here. There's your prime factorization of this. Now, remember, highlight the things that are in common to both. So look, I've got a 2 highlighted here. There's a 2 highlighted there. So I'm going to write it out here. There's our first one. I've got a 3 here and another 3 over here. So there's our next one. I've got 2. Nope. I got another 2. Nope. I got another 3 though. There it is. Look at that. I got another 3 common to both. And guess what? 2 times 3, which is 6, times 3, which is 18. Guess what? That is the greatest common factor to both. Now, if you want to prove that, no problem. Pop up your calculator right over here and go, okay, there's 144. Clear this. 144. Divide that by 18. And you, in fact, get 8. Now, take your 126, do the same thing, divide it by 18, and that should work in evenly. And it does. 8 and 7. And you see there's no other common factors to 8 and 7. So 18 is your greatest common factor. See how it works? So the factor tree that I taught you earlier and the factor trees that you did all the way back in grade 6 really help. Let's go on to this one. What if you have 3 of them? So what? Write them out the same way. Look, there's 150. There's 275. There's 420. Now, the nice thing about this one is it's got a 0 in it. Right away, I know that's 15 times 10. 15 is easy. That's 5 times 3. 10 is easy. That's 2 times 5. Let's skip over this one for a second. Let's go right to this one because it's virtually the same. That's 42 times 10. I know I can break 42 down into what? That's right, 7 and 6. Perfect. That breaks down to 7 times 2 times 3. That's the 6. The 10 can break down to 5 and 2. Okay, so there's my prime factorization of that one. Now, why did I leave 275 to the last? Because each one of these ends in 0, and you notice that the factor I used automatically is 10, right? Keep it simple. Now, look at this one. Not only does it end in 5, it ends in 75, which means 25 can go into it. So if I boot up my calculator here, and I go 275 divided by, and I know 25 is going to go into it, I'll have a lot easier thing to do. Check this out. That's 25 and 11. Look how easy this is now to factor if you choose a large enough of a number. Look, it's done. It's done. There's a prime factorization. 2 steps, done. Now, let's look at the things that we have in common. If you look, you have a common 5 here, and 5 here. So that's one of the numbers that we have in common. I'll just put it up here nice and big. Look at the other numbers that we have in common. This has a 3. Well, this one doesn't, so 3 won't work. This has a 2. Well, this one doesn't. 2 won't work. This has another 5. Well, this has got a 5. Perfect. But this one doesn't. So guess what? Your GCF for this thing is just plain old 5. That's it. So that factor tree takes all of the guesswork out of this, makes it such an easy and straightforward way to find your answer.